Hello everyone. In this video I'm going to show you how to calculate the equivalent capacitance of capacitive elements connected in parallel, thus showing this equation right here. Once again, we'll begin with KCL, the explanation of which is on the description section below. KCL says that the sum of the currents in one specific node of our network is equal to 0. But with capacitances, we don't have to do with currents, but with charges. Well, charges Q are proportional to currents. Essentially, current is the charge flow throughout the circuit. So the charge has the same properties as current. So according to KCL, in one specific node, if one current is entering the node, is considered to be positive, and the currents exiting through that node are considered negative. So the same applies for charges. So in the case of capacitors, we have that the total charge of our circuit is going to be equal with the sum of Q1 plus Q2 plus Qn. Now for capacitors, we have a different relationship about the capacitance, voltage and charge, which is this one. We have that Q is equal to the capacitance times the voltage of the capacitor. Let's denote them as K. And so by substituting this to our equation, we have that C equivalent times U of the circuit is going to be C1 times U1 plus C2 U2 plus Cn Un. Also, we know that parallel connected elements have the same voltage across their terminals. So U1 is equal to U2 is equal to Un, which is equal to the voltage of the source. And so we are left with C equivalent times U is equal to U times C1 plus C2 plus Cn. U and U are simplified, and we are left with C equivalent to be equal with the sum of the individual capacitances of our elements. Now, once again, this relationship is contrary to what we've expected when we had purely ohmic elements in parallel connection. This relationship is similar to the relationship that resistors had when they were connected in series and not in parallel. But with capacitors is the opposite.